Linus Pauling stands as one of the most extraordinary and complex figures in the history of 20th century science. A man whose intellectual brilliance spanned multiple disciplines, while his moral convictions drove him to become one of the most prominent peace activists of his generation. Born on February 28, 1901, in Portland, Oregon, Pauling is the only person ever to receive two unshared Nobel Prizes, for chemistry, 1954, and peace, 1962. This unprecedented achievement represents merely the most visible manifestation of a career that fundamentally transformed our understanding of chemical bonding, protein structure, and molecular biology, while simultaneously challenging the political and social orthodoxies of the Cold War era. The early life of Linus Pauling was marked by both intellectual curiosity and economic hardship that would profoundly shape his character and worldview. His father, Herman Henry William Pauling, was a pharmacist who died when Linus was only 9 years old, leaving the family in difficult financial circumstances. This early experience of loss and economic insecurity instilled in Pauling both a fierce independence and a deep appreciation for the value of education as a means of social advancement. His mother, Lucy Isabel Darling Pauling, recognized her son's exceptional intellectual gifts and encouraged his scientific interests despite the family's limited resources. Pauling's fascination with chemistry began in his teens when a friend showed him a small chemistry laboratory in his bedroom. The experience of observing chemical reactions and understanding their underlying principles ignited a passion that would define his entire professional career. He enrolled at Oregon Agricultural College, now Oregon State University, where he pursued a degree in chemical engineering. Even as an undergraduate, Pauling displayed the combination of theoretical insight and practical skill that would characterize his later research. He helped support himself by teaching chemistry to underclassmen, an experience that developed his legendary ability to explain complex scientific concepts in accessible terms. The transition from his undergraduate studies to graduate work at the California Institute of Technology marked the beginning of Pauling's emergence as a scientist of extraordinary promise. At Caltech, he encountered the cutting-edge research in physical chemistry and quantum mechanics that was revolutionizing scientific understanding of atomic and molecular structure. Under the guidance of Roscoe Dickinson and Richard Tolman, Pauling began to develop the mathematical and theoretical tools that would enable him to make groundbreaking contributions to our understanding of chemical bonding. His doctoral dissertation on the structure of molybdenite demonstrated the sophisticated approach to structural analysis that would become his signature methodology. By combining X-ray crystallography with theoretical calculations based on quantum mechanics, Pauling was able to determine the precise arrangement of atoms in crystal structures with unprecedented accuracy. This work established him as a leading practitioner of the emerging field of structural chemistry and laid the foundation for his later revolutionary insights into the nature of chemical bonding. The European fellowship that Pauling received immediately after completing his doctorate proved to be one of the most formative experiences of his scientific career. His time in Munich working with Arnold Sommerfeld exposed him to the most advanced theoretical physics of the era, including the quantum mechanical theories that were transforming scientific understanding of atomic structure. In Göttingen, he worked with Max Born, one of the founders of quantum mechanics, further deepening his understanding of the mathematical principles underlying atomic and molecular behavior. His subsequent time in Copenhagen with Niels Bohr completed his immersion in the quantum mechanical revolution that was reshaping physics and chemistry. These European experiences provided Pauling with a theoretical sophistication that few American chemists of his generation possessed. More importantly, they gave him the confidence to tackle fundamental problems in chemistry using the most advanced theoretical tools available. His return to Caltech in 1927 marked the beginning of the most productive period of his scientific career as he began to apply quantum mechanical principles to understanding the nature of chemical bonding. The development of Pauling's theory of chemical bonding represents one of the most significant intellectual achievements in the history of chemistry. His introduction of the concept of orbital hybridization provided a quantum mechanical explanation for the geometry of molecules that had previously been understood only empirically. By proposing that atomic orbitals could combine to form new hybrid orbitals with different spatial orientations, Pauling explained why carbon forms four equivalent bonds in methane, and why these bonds are directed toward the corners of a tetrahedron. The concept of electronegativity, which Pauling developed and quantified, provided a unified framework for understanding the spectrum of chemical bonding from purely ionic to purely covalent. His electronegativity scale, based on thermodynamic data, allowed chemists to predict the degree of ionic character in any chemical bond and to understand the relationship between bond polarity and molecular properties. This work established Pauling as the leading authority on chemical bonding and earned him international recognition as one of the most important theoretical chemists of his generation. His masterwork, The Nature of the Chemical Bond, published in 1939, synthesized his theoretical insights into a comprehensive treatment of chemical bonding that became the standard reference for several generations of chemists. The book demonstrated Pauling's remarkable ability to combine mathematical rigor with chemical intuition, presenting complex quantum mechanical concepts in ways that practicing chemists could understand and apply. The work's influence extended far beyond chemistry, affecting fields from material science to biology by providing a unified theoretical framework for understanding molecular structure and reactivity. The transition from his work on chemical bonding to biological applications marked another phase of Pauling's career that would prove equally revolutionary. His investigation of protein structure began with studies of the simplest proteins, including hemoglobin and antibodies. His application of X-ray crystallography and chemical analysis to these complex molecules revealed structural principles that had not been previously recognized. Most significantly, his discovery that sickle cell anemia resulted from a molecular abnormality in hemoglobin established the foundation for the field of molecular medicine. The concept of molecular disease that emerged from this work represented a fundamental shift in medical thinking. By demonstrating that genetic disorders could result from specific alterations in protein structure, Pauling opened up entirely new approaches to understanding and treating human disease. This work predated the discovery of DNA structure and the development of molecular biology, yet it anticipated many of the key insights that would drive biomedical research for decades to come. Pauling's work on protein structure culminated in his proposal of the alpha helix, one of the most important structural discoveries in the history of biochemistry. Through careful analysis of the constraints imposed by chemical bonding and the geometric requirements of protein chains, he predicted the existence of a helical structure stabilized by hydrogen bonds between amino acids. One of his foremost accomplishments was helping to create a model of the alpha helix, a key structure in proteins. The alpha helix became one of the fundamental structural motifs recognized in proteins and provided crucial insights into the relationship between protein structure and function. However, Pauling's most famous near-miss in structural biology came with his incorrect proposal for the structure of DNA. His triple helix model, with phosphate groups on the inside and bases on the outside, was quickly recognized as chemically implausible. The correct double helix structure, proposed by James Watson and Francis Crick, incorporated many of the principles that Pauling had established, but arranged them in the correct configuration. Nevertheless, Pauling was awarded the 1954 Nobel Prize for Chemistry for his research into the nature of the chemical bond and its application to the elucidation of the structure of complex substances. The period following Pauling's Nobel Prize in Chemistry witnessed his transformation from a purely scientific figure to a prominent public intellectual and peace activist. The atom bombs dropped on Hiroshima and Nagasaki were a turning point in Pauling's life. His scientific understanding of atomic structure gave him particular insight into the destructive potential of nuclear weapons, and he became convinced that scientists had a moral obligation to work for nuclear disarmament and international peace. His peace activism began with educational efforts to inform the public about the dangers of nuclear weapons and radioactive fallout. His book, No More War, published in 1958, presented a scientist's perspective on the nuclear threat and argued forcefully for international cooperation to prevent nuclear conflict. The book combined technical explanations of nuclear weapons' effects with passionate moral arguments against their use, reflecting Pauling's belief that scientific knowledge carried with it social responsibilities. The controversy surrounding Pauling's peace activism intensified during the height of the Cold War, when any criticism of American nuclear policy was viewed with suspicion by government authorities. His passport was revoked by the State Department, preventing him from traveling to scientific conferences and accepting international honors. The harassment he experienced from government agencies and the criticism from some scientific colleagues demonstrated the personal costs of taking unpopular political positions during a period of intense ideological conflict. Despite these pressures, Pauling continued his peace activism and was eventually awarded the 1962 Peace Prize for his opposition to weapons of mass destruction. The timing of the award, coming just as the Partial Test Ban Treaty was being signed, suggested recognition of his role in building public opposition to atmospheric nuclear testing. The Peace Prize established Pauling as one of the most prominent scientist activists of the 20th century and demonstrated that scientific expertise could be effectively marshaled in service of political and moral causes. The later phase of Pauling's career was dominated by his controversial advocacy for vitamin C and the development of what he termed orthomolecular medicine. Man is simply a collection of molecules, he remarked in 1956. Therefore, humans can be understood in terms of molecules. This reductionist philosophy led him to believe that optimal health could be achieved through the proper balance of nutrients and other molecules in the body. His 1971 book, Vitamin C and the Common Cold, became a sensation, kicked off a public controversy in the press, and helped convince millions of people to take more vitamin C. The book argued that large doses of vitamin C could prevent and treat common colds, a claim that challenged conventional medical wisdom and generated enormous public interest. The popularity of his vitamin C advocacy demonstrated Pauling's continued influence with the general public, even as it damaged his reputation within the medical establishment. The medical community roundly attacked both the findings and Pauling's credibility, noting that Pauling's well-established reputation was in chemistry and peace, but not nutrition. The criticism of his vitamin C work reflected broader tensions between Pauling's confidence in his ability to master any scientific field and the skepticism of specialists who questioned his expertise outside his primary areas of research. The establishment of the Institute of Orthomolecular Medicine in 1973 represented Pauling's attempt to create an institutional base for research into nutritional approaches to health and disease. He believed, with the right titration of molecules, doctors could cure a range of health problems, from the common cold to schizophrenia, autism, cardiovascular disease, and cancer. However, the scientific foundation for many of these claims remained weak, and the Institute's work failed to gain acceptance within mainstream medicine. The controversy surrounding Pauling's orthomolecular medicine work intensified when he began advocating vitamin C as a cancer treatment. His collaboration with Ewan Cameron on studies of terminal cancer patients suggested that high-dose vitamin C could extend survival and improve quality of life. However, subsequent controlled trials failed to replicate these results, leading to widespread rejection of vitamin C as a cancer therapy within the oncology community. Recent research has revealed that the route of vitamin C administration is critical, with intravenous vitamin C resulting in 30 to 70-fold higher plasma vitamin C concentrations compared to orally administered vitamin C. This finding has led to renewed interest in vitamin C as a potential adjunct to cancer treatment, though the clinical significance of these effects remains uncertain. The scientific legacy of Pauling's vitamin C advocacy remains contentious. Medical professionals believe that megadoses of vitamin C were ineffective and a waste of money, and the popularity of a theory proposed by a non-physician weakened their position of authority in health matters. The conflict reflected not only scientific disagreements, but also professional turf battles and concerns about the role of scientists in medical practice. Pauling's personal life was marked by a long and happy marriage to Ava Helen Miller, whom he met while she was a student at Oregon Agricultural College. Their partnership extended beyond the domestic sphere, as Ava Helen became actively involved in Pauling's peace activism and shared his commitment to social justice causes. Her influence on his political development was significant, as she often pushed him toward more radical positions on peace and civil rights issues. The couple had 4 children together, and Pauling was known as a devoted family man who encouraged his children's intellectual development while maintaining close relationships throughout his life. His son Peter became a prominent psychiatrist, and his other children pursued careers in science and education. reflecting the family's commitment to intellectual achievement and social contribution. The interdisciplinary nature of Pauling's contributions to science reflected both his intellectual curiosity and his belief that the most important scientific problems transcended traditional disciplinary boundaries. His work in quantum chemistry informed his understanding of chemical bonding, which in turn provided insights into protein structure and molecular biology. This synthetic approach to scientific research became increasingly important as the complexity of scientific problems grew throughout the 20th century. Pauling's pedagogical contributions were as significant as his research achievements. His textbooks in general chemistry and college chemistry educated several generations of students and established approaches to teaching that emphasized the connections between atomic structure, chemical bonding, and molecular properties. His lectures were renowned for their clarity and enthusiasm, and he trained numerous graduate students who went on to make important contributions to various fields of science. The institutional contributions that Pauling made to American science extended beyond his research and teaching to include service on numerous advisory committees and editorial boards. His role in establishing the reputation of Caltech as a leading center for chemical research was crucial to the institution's development into one of the world's premier scientific universities. His influence on national science policy, particularly regarding the role of basic research in national security and economic development, helped shape the post-war expansion of American scientific enterprise. The international dimensions of Pauling's career reflected the increasingly global nature of scientific research in the 20th century. His collaborations with scientists in Europe, Asia, and other regions of the world contributed to the development of international scientific networks that transcended political boundaries. His peace activism further reinforced these international connections and demonstrated the potential for scientists to contribute to international understanding and cooperation. The ethical dimensions of Pauling's career raise important questions about the responsibilities of scientists and the relationship between scientific expertise and social advocacy. His willingness to take controversial political positions demonstrated his belief that scientific knowledge carried with it moral obligations to work for human welfare and social progress. However, his advocacy for vitamin C and orthomolecular medicine also illustrated the dangers of extending scientific authority beyond areas of genuine expertise. The reception of Pauling's work varied significantly across different scientific communities and time periods. While his contributions to chemistry and structural biology were universally recognized and celebrated, his peace activism was controversial during the Cold War era, and his nutritional advocacy remained contentious throughout his later career. This varied reception reflected the different standards and expectations that applied to scientific research versus political advocacy and medical practice. The technological applications that emerged from Pauling's research had far-reaching consequences for multiple industries and scientific fields. His work on chemical bonding provided the theoretical foundation for the development of new materials, including plastics, semiconductors, and pharmaceutical compounds. His contributions to protein chemistry laid the groundwork for the biotechnology industry and the development of protein-based therapeutics. The historiographical assessment of Pauling's career has evolved significantly since his death in 1994. Initial accounts focused primarily on his scientific achievements and Nobel Prize recognition, but later assessments have given greater attention to his peace activism and the controversial aspects of his vitamin C advocacy. This evolving perspective reflects changing views about the appropriate role of scientists in society and the relationship between scientific expertise and public policy. The influence of Pauling's work on subsequent generations of scientists can be traced through the careers of his students and the development of research fields that build upon his contributions. The field of structural biology, which emerged from his work on protein structure, has become one of the most dynamic areas of contemporary biological research. His contributions to quantum chemistry provided the foundation for computational chemistry and molecular modeling, fields that have revolutionized chemical research and drug discovery. The philosophical implications of Pauling's approach to science reflected his belief in the unity of natural phenomena and the power of human reason to understand and control natural processes. His confidence in the ability of science to solve human problems from disease to war, represented an optimistic vision of scientific progress that was characteristic of mid-20th century American culture. However, his later career also demonstrated the limitations of this approach and the importance of remaining within appropriate bounds of scientific expertise. The public understanding of science was significantly influenced by Pauling's ability to communicate complex scientific concepts to general audiences. His popular books and lectures helped educate the public about atomic structure, chemical bonding, and the relationship between molecular structure and biological function. His peace activism also demonstrated how scientific knowledge could be applied to social and political problems, influencing public discourse about the role of science in society. The methodology that Pauling developed for structural research, combining experimental techniques with theoretical analysis, became the standard approach for investigating molecular structure throughout the biological sciences. His emphasis on the importance of precise measurements and rigorous theoretical interpretation established standards for scientific research that continue to influence contemporary practice. The interdisciplinary collaborations that characterized Pauling's later career reflected his recognition that complex problems in biology and medicine required expertise from multiple scientific fields. His work with physicians on vitamin C research and his collaborations with psychologists on orthomolecular approaches to mental illness demonstrated his willingness to cross traditional disciplinary boundaries in pursuit of scientific understanding. In conclusion, Linus Pauling's extraordinary career encompassed fundamental contributions to chemistry, biology, and peace activism that established him as one of the most influential scientists of the 20th century. His unique distinction as the only person ever to receive 2 unshared Nobel Prizes represents just one measure of his remarkable achievements across multiple domains of human endeavor. His work on chemical bonding revolutionized our understanding of molecular structure and provided the theoretical foundation for much of modern chemistry and molecular biology. His peace activism demonstrated the potential for scientists to contribute to social progress and international understanding, even at significant personal cost. His later advocacy for vitamin C and orthomolecular medicine, while controversial and largely rejected by mainstream medicine, reflected his continued commitment to applying scientific knowledge to human health problems. The complexity and contradictions evident in Pauling's career mirror the broader tensions that characterize the relationship between science and society in the modern era. His confidence in the power of scientific reasoning led to both groundbreaking discoveries and controversial claims that exceeded the boundaries of his expertise. His willingness to take unpopular political positions demonstrated both intellectual courage and the risks associated with scientist activism. His influence on multiple generations of scientists, through his research, teaching, and public advocacy, established him as a pivotal figure in the development of 20th century science and its relationship to broader social concerns. Whether judged by his fundamental contributions to scientific knowledge, his role in nuclear disarmament efforts, or his complex legacy in nutritional medicine, Linus Pauling remains one of the most significant and fascinating figures in the history of American science, whose work continues to influence scientific research and public policy discussions to this day.